Hello, my name is Garret Stearns, and today I'll be looking at NHL game data to determine how useful it is in making predictions to the home team score. I'll be exploring this by looking at these 6 research questions and answering them in detail over the following presentation. For this project, I collected my data from data538.com. I removed all but 78 rows and removed 16 variables that weren't relevant to the analysis. I have 2 categorical variables, OT with 3 categories and playoff with 2. And I have 4 continuous variables, home team score, home team's expected points, overtime probability, and home team pregame rating. For our first research question, we ran a distribution on the home team score. And based on our sample size of 78, we can conclude with a 95% confidence that the home team score ranges from about 2.91 to 3.78, with a margin of error of 0.43 and a mean of 3.35. So this tells us that if we're making predictions to the home team score, this is a range that we're going to typically want to be in. For the next research question, we ran a fit model between the X variable playoff and the response Y variable home team score to see if there was a difference in the home team score between playoff games and non-playoff games. We had a high p-value of 0.765 and a t-score of 0.29665, so we failed to reject HO and can conclude that the means between playoff games and non-playoff games are statistically the same, with a small difference in sample means of just 0.2712. So when making predictions to the home team score, we know that they should be relatively statistically the same between playoffs and non-playoff games, with a mean in non-playoff games of 3.33 and a mean in playoff games of a slight difference in just 3.6. Next, I ran another fit model, this time using the OT category variable as our X variable in the fit model, to see if the home team score would vary between the different overtime statuses. Again, we failed to reject HO due to our high P score of 0.17, which is above the 0.05, and we also had an F stat of 0.18. So this tells us that the score between the different overtime statuses are going to be statistically the same. And so when making predictions to the home team score, we would keep that in mind and understand that it won't make too much of a difference if the game goes into overtime or shootouts or none. In this research question, we just looked at the proportion of playoff games to see about how many games end up being playoff games. And we concluded with about 95% confidence that the mean proportion is going to be about 6.4%. Games being playoff games, but that ranges from about 2.8% to 14.14% of games being playoff games, with the margin of error of 3.87%. So this really just tells us that not a whole lot of the games are going to be playoff games, and actually we can see that in this data set, only 5 games were playoff games, whereas 73 games were non-playoff games. In the next research question, we looked at if the overtime categories were proportionate across all games. So to see if an overtime status of OT is just as likely as an overtime status as an of none. We rejected HO in this one due to our low p-value that was less than 0.0001. We also had a high chi-square of 86.06, which tells us that a lot of the change is explained by this model. And so we know that the overtime statuses are not distributed proportionately across all games, and so we know that it's going to be much more likely for a game to not go into overtime or shootouts than it is for a game to go into overtime or shootouts. For our last research question, we ran regressions to see which one of these variables actually has the best predictive ability on the response Y variable of home team score. We started with 4 variables, and through the pruning process we removed the ones with p-values higher than 0.05 each regression, and we ended up with just one variable, the home team expected points, which did show a strong relationship with the home team score as indicated by our extremely low p-value. However, our F statistic is just 17.34, which tells us that only 17.34% of the variability in the response Y variable home team score is explained by our X variable home team expected points. So really this model is not so good for actually making predictions to the home team score. In conclusion, we determined that our data set is not very useful at all for making predictions to the home team score. We determined that the home team score ranges from 2.91 to 3.78. However, in reality, this isn't very useful due to the narrow range and that games will only come out to a whole score. We determined that the home team score is not statistically different between playoff games and non-playoff games, and similarly, it does not statistically differ between the overtime categories. So whether or not it's a playoff game or it goes to overtime or it goes to shootouts isn't helping us make predictions to the home team score. We determined that the proportion of playoff games ranges from 2.8% to 14.14%, so there's not a lot of them, and that there are a lot more games, 82.28%, that do not go to overtime or shootouts. But again, this doesn't really help us because whether or not it's a playoff game or it goes to overtime or shootouts isn't helping us make predictions. Lastly, we determined that there is a small relationship between our X variable, home team expected points, and the response Y variable, home team score. Again, though, this isn't really helping us make predictions, as only 17.51% of the variability in the response Y variable is explained by our X variable, and that response Y variable, again, is the home team score. Lastly, lesson learned. I had a big lesson learned in this project where I needed to keep a lot more data set rows. I only kept 78, and my data ended up not verifying for my proportions, as I did not have 10 or 5 data points per category. And that concludes the presentation. Thank you for watching.